today, this morning. Colleagues, let me also take this opportunity to thank you for the hard work throughout the year that now it's culminating to this end, last interaction of the year as we discuss this memo discussion, as we discuss this paper. Thank you very much for the hard work, and we know that you have done your best throughout the year for our learners, and hopefully they will also show their appreciation by passing the paper, showing that you have worked hard throughout the year. Thank you so much. I'm going to run through the memo, this memo, simply because my battery life is very low and I don't want to waste time. So colleagues, with question 1, I don't think if there's anything you'll indicate, but I'll just pass question 1 and go straight to question 2. And at the end of each question, we will have questions and answer whatever we need to answer, or take note, and we will get back to you later on. What else? Okay, do not forget, colleagues, to also fill in the register. The memo discussion will be recorded for all the colleagues that will watch later, and then also fill up the register, fill in the register as and when you watch the memo discussion. And it is also streamed live on YouTube. So I think everything will be just smooth sailing and running smoothly. Let us check question. I'm sure you have your question papers. I'm not going to project or share the question paper with you. I'll just share the memo as is shown there on your screens. Question 2.1. A cordless drill has an 18-volt battery with a mass of 410 grams. It rotates at a speed of 210 revolutions per minute. Question 2.1.1. What is the rate at which the drill rotates in revolutions per second? So it means learners need to convert from RPMs to RPS. So 21 revolutions is indicated there on the memo 2.1.1. For 1 minute, we are going to divide it by 60, and then 1 mark for that sum, 21,000 divided by 60, which is 60 seconds, multiply, that will be equals to 35 revolutions per second. Then for giving that 35 RPS, 1 mark as well. Then 2.1.2, convert 410 grams to kilograms. So for converting that, on the memo, we said 410 divided by 1,000 equals to 0.41 kilograms. So it's 2 marks, 1 mark for dividing 410 by 1,000 and 1 mark for the answer. So I will also like to ask you not to penalize learners if they did not include the SI unit, because on the question paper, they know they are converting from grams to kilograms. We know that they should write it there, but please do not penalize. Give full marks even if they've just written this 410 divided by 1,000 equals to 0.41. If they forgot to put the kilograms, please do not penalize them. But we know we must stress that every time they must show SI unit. But because they were already told to convert to kilograms, do not penalize. 2.1.3. How many, or the electrical energy consumption for the drill is 70.21 kilowatt hour. So question 2.1.3, how many seconds will be used by the drill that consumes electrical energy of 70.21 kilowatt hour. So we are just converting an hour to seconds there. So it's 2 marks for the correct 3,600 seconds, 2 marks there. You award those marks there on the answer. Colleagues, question 2.1.3, I think we can also just split. Let us just split those marks. Let us award the 1 mark for them showing that is 60 by 60, 1 mark there. And then for the final answer, 3,600 second, 1 mark. Let us split these 2 marks, please, colleagues. Let us split the marks, please, so that we do not penalize our learners a lot. But if they have just written the correct answer only and not showing how it came about, still give full marks. But we can just split the marks as well for them, because sometimes they might say 60 by 60 and then get an incorrect answer there. So it means they will forfeit the 2 marks if the final answer is not 3,600 seconds. But if they've shown that it's 60 by 60, getting that final answer incorrect, it means they will get that 1 mark. Let us give them, let us split, but if they have written it as just 3,600 seconds, award the 2 marks. Let us move to question 2.1.4. Convert 70.21 kilowatt to watt. So that conversion, for them to convert that kilowatts is 1 mark. Then even if they've shown that 1 kilowatt, we know that is 1,000 watts. So therefore, it means it's 70.21 multiplied by 1,000, which will give them the 70,210 watt. 1 mark, just 1 mark for that conversion, colleagues. Let us move to question 2.2. Question 2.2. List any 3 of the 7 fundamental units of the SI system. So they can mention any one of these. 1 will count for 1 mark. Meter for length, seconds for time. As it reaches there, as it is written there, just 3 marks. Choose any 3 correct, 3 marks. Then we go to question 2.3. Question 2.3, convert the following quantity to a required unit and write it in the scientific notation. There is the value given to our learners, and then they are supposed to convert it from meters to kilometers. Now, for that conversion, it was originally awarded 2 marks for the final answer. However, let us also split if they have shown, because now the question said convert the following from meters to kilometers, and then write that in the scientific notation. You split the marks. If they've converted correctly from meters to kilometers, award 1 mark. And then for the final answer, also award 1 mark. We can split those 2 marks that way, for converting from meters to kilograms and for writing now in kilometers as a scientific notation. All right, this brings us to the end of question 2, which is total marks is 12 marks. I will open for any contribution, question, or anything. Colleagues, are you still with me in the meeting? All right, I'll assume you are. Oh, there's a hand. Ndlalankulu. You can unmute yourself and ask Ntate or ma'am.
Thank you so much, ma'am. Good afternoon.
Afternoon, sir.
So much, ma'am. On question 2.2, The learner says to list any three fundamental SI units. So maybe if they are only they have written only the symbols for the measuring units, do we also award marks on that?
Like M for length, S for time.
Just the symbol for the unit only.
Okay, am I hearing you correct? Like, for instance, let's take the first one. The learner did not write meter, just wrote the unit M for length.
Yes, ma'am.
No, I think we can award that. Let us not penalize them. And if, like, for instance, we'll penalize if, like, let me say, for instance, let's check MPS. MPA, if he has written a small letter A, then it will be incorrect. As long as the unit is denoted correctly, then there's no problem. You can award the marks.
Thank you so much, ma'am.
Okay, sir. Colleagues, I will move to question 3. Question 3, I'll just read it quickly. Busi walks from her house in an easterly direction to the shop and back again. On the way back, she stops at a certain point to rest. The straight line distance from her house to the shop is 680 meters, and from the shop to the point of rest is 310 meters. So question 3.1, distinguish between scalar and a vector quantity for 4 marks. So scalar is a physical quantity with magnitude only, 2 marks, but no direction. They can just say, even if they've just said physical quantity with magnitude only, you award the 2 marks if they've ended there. Or if they've continued to say, but no direction also, it will be 2 marks. Vector is a physical quantity with magnitude and direction, then it's 2 marks. 4 marks for 3.1. Therefore, 3.2, draw a vector diagram that illustrates Busi's entire motion until point of rest. So the entire motion, she traveled from her house 680 meters in an easterly direction, and then she went back to her house 310 meters to a point where she rested. So this is the vector diagram. It's not drawn to scale. So it's just a drawing that indicates that a vector from her house to the shop is longer than the vector where she was walking back to her house and stopped somewhere to rest 300 meters away from the shop. This is how it is. So 2 marks for indicating that journey or vector from her house to the shop, and then the 2 marks again for the return up to where she stopped. That will give that 4 marks. Then we go to 3.3.1. From the house to the point of rest, now calculate the distance that Busi walked. She walked the entire distance from her house until the point where she stopped is 680 meters plus 310 meters, 1 mark for indicating these 2 values, and then that will be equal to 990 meters, another 1 mark for that. So it's 2 marks for 3.3.1. 3.3.2, calculate the displacement of Busi's motion. Now her displacement will only be the distance from where she stopped to the house, to back to the house. Therefore, 680 minus the 310. That sum is 1 mark for that, for indicating that you're going to subtract 310 from 680, and then the final answer, which is 370 meters east. That is her displacement. Then 1 mark for the east, the direction. Right, okay, this brings us to the end of question 3, which is 13 marks. Colleagues, this is your opportunity. If I don't even see your hand, that is, you have raised it, you just unmute yourself and say your question or whatever it is. I might miss some hands. I don't see anything and I don't hear anyone. I will move on to question 4. Generally, this is easy to mark. There are no just tricky words. Question 4, I'll just read. A motorcycle is 50 per hour. When the dog runs across the road from west to east, the driver steps on the brakes for 3.7 seconds to avoid hitting the dog. The motorcycle's velocity after 3.7 seconds is 49 kilometers per hour. Now, define the acceleration of an object. Acceleration is defined as the rate of change of velocity. It's 2 marks for that. Then 4.2, what is the direction of the velocity of the motorcycle? The direction of the motorcycle is north. It's north, 1 mark for north. You can also accept, because you can also accept capital letter N. We know it stands for north, and whenever we give them compass, sometimes we show a direction as N, S, W, and all of that. So accept N. Then 4.3, what is the direction of the acceleration of the motorbike after the driver applies the brakes? And give the reason for your answer. Now 4.3, the direction of the acceleration of the motorbike is south. 1 mark for that, because now the motorbike will be decelerating, so we don't even use that deceleration, but it will be now south. The acceleration will be south, and it accelerates in the opposite direction of the movement. Remember, the initial movement was northwards, so it will be now south. And for giving the reason that it accelerates in the opposite direction of the movement, or they could say velocity decreases with time. 1 mark for those reasoning. So the total mark for 4.3 would be 2 marks. 4.4, convert the 65 kilometers per hour to meters per second. To convert that, 65 divided by 3.6, 1 mark for that, and the final answer 18.06 meters per second, 1 mark for that as well. Some learners can go to an extent of indicating how the 3.6 came about, that they multiply 65 by 1,000 divided by 3,600 times 3,600 seconds. Even if they've done that, it would be 1 mark for showing that division and 1 mark for the final answer. 4.5. Calculate the acceleration of the motorcycle. Now, calculating the acceleration, 5 marks. For the correct formula, acceleration is equals to change in velocity over change in time, 1 mark for that. Or even if it is expanded, we can accept acceleration VF minus VI over delta T, still fine, 1 mark for that formula. Then the substitution, the whole numerators substitution, the 13,6, 1, which is what is that velocity that the acceleration 49, the 49 kilometers per hour converted to meters per second, even the 65 kilometers per hour converted to 65 seconds, to meters per second, 1 mark for that, the whole substitution, and the change in time, also award 1 mark for that. Therefore, that is equals to minus 1,2 meters per second, no mark at this stage. The mark will be when the answer has been interpreted, that is 1,2 meters, the acceleration is 1,2 meters per second squared. Colleagues, let us correct that. It's a mistake. Acceleration will be the SI unit. Let us correct meters per second to per second squared. 1.2 meters per second squared south. 1 mark for interpretation of the direction south. So the total for that is 5 marks. 4.6. For 4.6, the motorcycle now travels at a constant speed of 49 kilometers per hour for 50 seconds. Calculate the distance in kilometers. That is so that speed is equals to distance over time. For that formula, award 1 mark. And then for substituting the speed, which is now the 49 kilometers per hour, which is now converted to seconds, 13, is converted to meters per second, is 13,61. That substitution, 1 mark. They can either substitute it as converted or as 49 kilometers per hour as option B. Now, distance over time for substituting the 50, which is time, 1 mark. And now this time around, the time is converted there. Now the distance will be equals to 0,68 kilometers for both options. I don't know why this is highlighted. The Afrikaans part was highlighted by mistake. There's nothing there. It was just highlighted by mistake. So that will count for question 4.6 will count 4 marks. And that will bring us to the total of 16 marks in question 4. Any questions, colleagues? Okay. Question 5. A 165 kilogram box is at rest on the horizontal table with a rough surface. 3 people, X, Y, and Z, each pulls the box with forces of 230 newtons, 180 newtons, and 143 newtons, respectively, in direction as shown in the diagram. The box remains at rest. 5.1. define the term equilibriant. The equilibriant is a force that has the same magnitude as the net or the resultant force of the system, but acts in an opposite direction. Two marks for that definition. And then 5.2, calculate the magnitude of the weight of the box. So for calculating that, for the formula, Fg equals to mg, 1 mark. For substituting the mass and the gravitational acceleration, 1 mark for both of them, 1 mark. And then the final answer is 1,617 newtons, 1 mark. That counts for the 3 marks. There it is, 5.3. Write down the name of the force exerted by the surface perpendicular on the box, 1 mark. That force is a normal force, 1 mark for normal force. Even if they've written just it's normal force, let us take it as like that. Normal force is fine. Normal force, or if they've just indicated as F subscript N, it's still correct. Let us accept. Let us not penalize one. It's correct. It's F normal force. There it is, 5.3, 5.4. 5.4, write down the magnitude and direction of the force in question. 5.3, the normal force, the magnitude and direction of this. It is the same as the Fg, which is 1617 newtons, 1,617 newtons. Now upwards, acting upwards. 1 mark for the numerical answer there, 1617 newtons, and 1 mark for the direction upwards. It's 2 marks for that. Then we go to question 5.5. 5.5, draw a labeled free body diagram showing all the forces acting on the box for 6 marks. We have 6 forces acting there. Let us check the marking criteria. But before we go to make sure that they've indicated that dot. But if they've drawn a force diagram, do not penalize, colleagues. If they've drawn a box, there's a force diagram, do not penalize, but make sure that all the forces are touching the dot or that box, if they've drawn a box, and arrows are there. That is checking the diagram. Now labeling, let us see the accepted labeling. For the weight, which is Fg, we accept weight, or gravitational force, or the weight as it's written in full, we accept 1 mark. For the normal force, we will accept Fn, and then N, capital N, also accept, or we will also accept written as normal force, 1 mark. Then for friction, small letter F for friction, 1 mark. We also accept F static, Fs, like that, friction or static frictional force. All of those are acceptable. And finally, for the applied force for the 230 and 143. Also for the 185 newtons, we will accept F for the force F applied, Fa, or numerical values given to those different forces acting on that block. The total for this is 6 marks. Forces get 3 marks, all the applied forces get 3 marks, and then for normal force, F for the weight and also for the kinetic friction, 6 marks. Right? Let's move on to 5.6. 5.6, calculate the resultant of the forces exerted by the 3 people, person X, Y, and Z. Now the resultant there is equals to 230 plus 143 because they're in the same direction, minus 185 in an opposite direction. That's why it's minus. 1 mark for this. Everything should be correctly substituted there. 1 mark. And then for the answer, numerical answer 188 newtons with the SI unit, 1 mark. And the direction right, 1 mark. 5.7. 5.7, write down the magnitude and direction of the force that keeps the box in equilibrium. Magnitude, it will be 188 to the left, 188 newtons to the left. And 1 mark for the 188 plus the SI unit, and 1 mark for the direction. 5.8, in this scenario, except for equilibrium, what other name does this force that keeps the box in equilibrium have? The other name for that is, in this scenario, is friction. It's friction, therefore 1 mark for that. Question 5 comes to an end with 20 marks. I'll just pause for a minute so that to give you a chance for questions. Right, I don't hear anything, colleagues. Question 6, a learner analyzes information given of a laundry pack. The dimensions are as follows, as shown in the diagram. Right, now question 6.1.1. The laundry pack is a lever. Write down the names of the positions marked A, B, C. So for point A, it's an effort, 1 mark. Oh, Jehovah, the battery now is. Colleagues, should my laptop die, I don't know, let us just rejoin the meeting, because I tried to join the phone, I could not. So let us rejoin the meeting, because at 2 o'clock my electricity will be back. We will just rejoin to, if should it cut before 2 o'clock. I'm hoping it will just sustain me a bit. Then 6.1.3. Define the term mechanical advantage. The definition, the mechanical advantage is the ratio of the load to the effort, 2 marks for that. Then 6.1.4, the mechanical advantage of the laundry pin is 0.75. Calculate the distance x as shown in the diagram. Now for calculating that mechanical advantage, the formula, distance of the effort over the distance of the load, or the other formula, 1 mark for any of the two. And then for substituting everything, 1 mark. Therefore, the distance will be now 30, then we add the 40. It's 40, we added the 30 from the diagram, distance between the fulcrum and the effort there. Then it's equal. It has 1 mark for that. So its total is 4 marks. 1 for the formula for the whole substitution. Everything should be correct in the substitution. The mechanical advantage should be substituted correctly, and the distance also there from the effort. Also the 30, everything should be correct there. 1 mark. Then the final answer indicating that after getting the 40 millimeters, now the whole distance x will be the two distances added together. Now the 30 plus 40, 1 mark for that, and final answer with SI units, 70 millimeters, 4 marks. Therefore, 6.2.1, 6.2.1. And I'm not going to read the statement. I'm just going straight to the question. Write down the two conditions for a system that is in equilibrium for 2 marks. Net force, the net force equals to 0, 1 marks, one condition, the net force should be equals to 0, or the net moment equals to 0. Therefore, it's 2 marks, 1 mark for that, for the force and the moment equaling to 0, 1 mark, 2 marks for the whole thing. 6.2.2, calculate the distance R1 and R2 as shown in the diagram for 4 marks. Now, calculating the distances, for a formula, sum of clockwise moment is equals to the anti-clockwise, sum of the anti-clockwise moment. Therefore, it's 1 mark for the formula, either formalize, or this one of the applied force and the perpendicular distance. They can either award mark for that or here. Then for substituting, or this 1 mark, for them to get this 1 mark, everything must be substituted correctly. The force plus the acceleration, 9.8 equals to R1. 20, the force of 20 multiplied by 9.8 equals to R2. Everything there is 1 mark. And therefore, the other mark that they're going to get after manipulating this, R1 will be equals to 0.49 meters. Therefore, that will mean that R2 will be 1.6 minus the 0.49 of the R1, which equals to 1.11 meters. You 1 mark for that as well. The total there is 4 marks. Then question 6, the whole total is 16. I'll give this opportunity to you colleagues for any questions. Question 7. Let's go there. Question 7. A crane in a scrapyard lifts a car of a mass of 9 kg. The cable breaks when the car is 10 meters above the ground. The car falls and hits the ground at 14 meters per second. Ignore the effects of air resistance. Right, then question 7.1, define the term kinetic energy. Kinetic energy is the energy of an object due to its motion. 2 marks for that. Then 7.2, calculate the gravitational potential energy of the car at the height of 5 meters above the ground. Now, EP equals to mgh. 1 mark for the formula and 1 mark for correctly substituting everything, mass multiplied by g multiplied by the height, the 5. And the final answer with the correct SI unit is 46,550 joules, 1 mark. The total there is 3 marks. And then 7.3, calculate the velocity of the car at the height of 5 meters above the, oh yes, 7.3, yes, calculate the velocity of the car at the height of 5 meters above the ground. Okay, now for the formula of mechanical energy, EP plus kinetic energy at 10 meters is equals to mechanical energy at 5 meters. So 1 mark for that. You can award mark for any of the 2 formulas. It's any mark, just 1 mark for each. Not each, anyone. Colleagues, I am back again. I'm just going to share my. Can you see the memo, colleagues, on the screen? Mr. Nambani? Anyone in the meeting?
Yes, ma'am, we are present.
Okay, thank you. You can see the memo. Is it projected on your screens?
100% 7.3.
Thank you, ma'am. Thank you so much. Colleagues, let me apologize for that. You know, it's a story of our lives. With ESCOM and electricity. So I'm going to continue, colleagues. We're at question 7 without wasting any time. We were at question 7.3, where they were supposed to be calculating the velocity of the car at the height of 5 meters above the ground. So for any of the mechanical energy equation, 1 mark, either the short version or the expanded one mark, any of those two. And then for the substituting everything correctly on the right hand side, 1 mark. The plus 0 must also be there to show that at the top it was stationary there. There was no motion, therefore it's 0 there. And then the left-hand side substitution, also everything correctly substituted, 1 mark. For the final answer, velocity will be 9.9 meters per second downwards. 1 mark for the whole answer. The numerical value, 9.9 meters per second SI unit must be there. And for the direction, all of that, 1 mark. Then the total for 7.3, it's 4 marks. Then 7.4, will the value of the car's mechanical energy just before it hits the ground be greater than, less than, or equals to the mechanical energy at the height of 5 meters? Explain your answer. It will be equals to, then it's 1 mark for that. Mechanical energy is conserved because it's an isolated system. 1 mark for that. So it means for substantiating is 2 marks, and for saying equals to is 1 mark. 3 marks for 7.4, and the total for for question 7, it's 12. I will give you a minute for anything, colleagues, questions. If you have anything, you'll just unmute yourself and just go ahead and say it. I don't hear anything. I'm going to move on to question 8. Question 8, it reads thus: static electricity is a study of charges at rest. The apparatus shown is used in the school laboratory during the kind of charge experiment. The kind of a charge experiment, right? 8.1, write down the name of the device in the picture above for 1 mark. It's a Van der Graaf generator, 1 mark. And then 8.2, name one way in which objects can be charged. One way. The objects could be charged by friction or by contact. Any of those is 1 mark. Then 8.3, consider two charged sphere, A and B, below, which hang from the string attached to a ceiling. Colleagues, can I pause for a minute and close the door? What's going on? Right, colleagues, consider two spheres charged A and B below, which hang from the string attached to a ceiling. Sphere A has a charge of negative 3.6 coulombs. Then question 8.3.1, state the principle of conservation of a charge for 2 marks. The net charge of an isolated system remains constant during any physical process for that 2 marks. Or they could say charges cannot be created or destroyed, but only transferred from one object to another. Then it's another 2 marks. Either one is correct. Right, and then 8.3.2, explain why the spheres do not hang vertically straight down the strings by referring to the charge on each sphere. Right, the spheres attract each other, 1 mark for mentioning that, so that charges on spheres must be of opposite nature, 1 mark. It means the two spheres are oppositely charged. For an example, learners don't have to mention that one must be positively charged or other one must be negatively charged, vice versa. Or they could just give that as a reason that sphere A must be positively charged and sphere B negatively charged, or vice versa. You can award a mark for mentioning that, showing that the charges are of opposite nature on the spheres, right? And then, no, that's it. 1 mark for that. Or they could say, also accept spheres have unlike charges. You can also award a mark if they've said that. So the 2 marks can be awarded saying any of those statements. Then 8.3.3, the spheres move closer to each other and make contact. Which, is there a question? Oh, okay, I heard something, sorry. The spheres move closer to each other and make contact. Which particle, for example, neutrons, electrons, or protons, move from one sphere to another sphere? It's for 1 mark. We know that only electrons can be transferred. It's electrons, 1 mark for that. Now 8.3.4, the new charge on each sphere after contact is 0.6 coulomb. Calculate the initial charge on charge B. Now, for us to calculate that, we need a formula for a new charge is equals to the sum of the 2 charges A and B divided by 2. Therefore, the new charge we are given that is 0.6. For that substitution, 1 mark. And then for the whole substitution on the right-hand side, 1 mark, everything correct. Therefore, charge B will be 4.8 coulombs, 1 mark. Then the total for 8.3.4 will be 4 marks, and the total for the question 8 is 11 marks. I will pause a bit before I start with question 9 so that to give opportunity for questions. If nothing, I will move on to question 9. Question 9, a circuit contains a 9-volt battery, 2 resistors connected in parallel with the battery, a switch connected to a positive terminal of a battery, and an ammeter that measures the total current of the circuit R1, or total current in the circuit. Then R1 equals to 2 ohms, R2 equals to 3 ohms. Right, so now 9.1, draw the above mentioned circuit and indicate all the symbols and values. That is question 9.1. Now there is a drawing of a circuit showing everything. Now let us check the marking criteria. Ammeter connected in series, 1 mark. R1 connected in parallel to R2, 1 mark as well. Or accept if they've indicated 2 ohms where R1 is, then is correct. You can accept that. And also for R2, we'll accept the 3 ohms, 1 mark. Battery shown, 1 mark. Switch connected to a positive terminal of the battery, 1 mark for that. Right. There's a total is 5 marks. What is it? 5? Yes, it's 5 marks. 1, 2, 3, 4, 5. 5 marks for question 9.1. 9.2. Indicate the direction of the conventional current flow on the circuit by drawing an arrow on the conductors. Now that arrow should be now indicated on the diagram there. That arrow should be indicated there, and then you'll award 1 mark for question 9.2. Correct direction. Arrow indicates the current flow from positive terminal to negative terminal, 1 mark if it's placed in the right direction. Now 9.3, will the same amount of current flow through each of the resistors? Give a reason for your answer. No, because current divides in a parallel circuit. 1 mark for saying no, and the current divides in a parallel circuit. And since the resistors value differ, 1 mark for indicating that the value of the resistors are not the same. And now the flow will not divide evenly. For indicating that as well, 1 mark. So there is your 3 marks. For 9.3. 9.4.1, calculate the total resistance of the circuit. RP total, there it is, equals, for the formula, 1 mark. And now for correct substitution, 1 mark for both substitutions should be correct to get that mark. And therefore R parallel is 1,2 ohms, which is 3 marks. This brings us to a total of 12 marks for question 9. Question 10. Question 10, study the diagram below and answer the questions that follow. There is a diagram, and then 10.1, define the term electric current for 2 marks. Electric current is a rate of flow of charge, 2 marks. 10.2.1, calculate the reading on AT. So ammeter reading will be the 2 ohm plus 5 ohm equals to 2 plus 3 equals to 5. 5 amperes plus 3 amperes equals to 5 amperes for the whole circuit. What is the 10.2.3? 10.2.2. Calculate the potential difference of the battery. The potential difference of the battery, the EMF is equals to the 12 volts plus the 6 volts. Then it gives us the 18 volts. 1 mark for adding 12 volts plus 6 volts, which gives us 18 volts, 2 marks for that. Then 10.2.3, calculate the voltmeter reading across resistor 2. We know that the total resistance for those parallel connections 12, then we subtract 3 for R1, then R2 will be 9 volts. For subtracting 3 from the 12 volts from the 3 volts, 1 mark, and for the final answer with the correct SI unit, 1 mark. For R2, for V2, yes, resistor 2, and then 10.3.1. Charges flow through R4 in 1 minute. For R4, calculate the amount of a charge that flows through it. For R4, 10.3.1. For the formula for the to calculate the charge, 1 mark. Then the substitution 5 by 60 is 1 mark. Therefore, the charge will be 300 coulombs, 1 mark for that. The SI unit must also be there, 3 marks. 10.3.2. Calculate the energy transferred in 1 minute. Now, for the formula of work, it's 1 mark for that. Then the correct substitution, 6 volts multiplied by 300, the charge equals to 1,800 joules. SI unit should also be there for that mark to be awarded. Now the total for 10.3.2 is 3 marks for a formula substitution and the answer with the correct SI unit. .4, write down 2 factors that influence the resistance of the conductor and explain the effect of each on the resistance for 4 marks. Now we're going to, there are 4 given, you choose any 2. The temperature is one factor that will influence the resistance. The warmer the conductor, the greater the resistance. Right. Thickness, also 1 mark for that. We are missing ticks for explaining why or how the temperature will affect that resistance. Let us just put on the one tick for that. For each of them, the explanation to thereof 1 mark. Let us put the ticks there, but we know eventually we're just going to choose 2. The thickness of the conductor. Then how does the thickness affect the resistance? The thinner the conductor, the greater the resistance, 1 mark. Or we could say the length also affects the resistance. How does the length affect the resistance? The longer the conductor, the greater the resistance. 1 mark as well as 2 marks for each, for mentioning the factor and explaining. The type of a material also, 1 mark. That will depend on the intrinsic properties separately determined by a specific resistance, 1 mark for a material. A different type of material gives a different resistance to the conductor. So there are 4 mentioned with explanations. Choose any 2. Don't forget to add the ticks for the explanations. And then 10, okay, question 10, it's 18 marks, the total. It's 18 marks, and that gives us the grand total of 150 for the paper. I will pause to offer opportunity for questions. Colleagues, let me thank you again and also apologize for the breakage. And I know it took your time as well, as we don't have that time. Thank you for connecting in. And for those colleagues that maybe they will connect later on, remind them to feed in the register. Mr. Nambani will also make this recording available so that they can watch later, and after watching it, fill in the register. Thank you very much, colleagues. If there isn't anything, thank you. We will disconnect. Bye, colleagues. Is there anyone still in the meeting? Colleagues.
Thank you, ma'am.
Okay, it's only you, Clarissa, ne? Oh no, I see there are lots of people, a number of people. Thank you. All right, thank you, colleagues. Bye-bye.
Bye, ma'am. Thank you.
Thank you.